The average weight of women in the United States is 164.7 pounds. These weights are normally distributed with a standard deviation of 37.5 pounds. If one woman is randomly selected from the US population, what is the probability that she weighs between 145 pounds and 175 pounds? Okay, so again, it says that the weights are normally distributed, so we're going to draw a bell curve as a visual aid, and then we'll label a z-axis on the bell curve and an x-axis that'll correspond to weights. The center of the z-axis will be 0. The center of the axis for weights will be centered at the mean, which is 164.7. Then we'll put the standard deviation off to the left here so we know what that is, and it's right there when we need it. And then we're looking for weights between 145 and 175. So 145 is on the left-hand side of the curve. It's very important that you put it appropriately with respect to the mean, right? So it's got to be less than the mean, so it's on the left-hand side of the curve. And then 175, the other number we're interested in, right? That's above 164, so that'll be on the right-hand side of the curve. So we're looking for the span between these two numbers, or the area under the curve between these two numbers, and that means we're looking for the shaded region I've just drawn. So I'll need to convert both of these into z-scores. Now we've converted the 1.75 into a z-score already, so I'll just remind you of what that came out to be. It was 0.27, so I'm just going to write that one in. And then for the 145, it'll essentially be the following z-score, right? So I'm going to convert that into a z-score by doing the 145, the score I want to convert, minus the mean of 164.7, divided by the standard deviation of 37.5, right? All right, so let's see what that gives you. 145 minus the mean of 164.7. Close it up and divide by 37.5. And when we're done, we get the decimal answer to two decimal places of minus 0.53. Right, rounding off to two decimal places, this 5 makes this 2 become a 3, so it's minus 0.53. So minus 0.53. All right, if I look up 0.53, let's see what that gives me. So here's 0.5, and 0.50123 gives me 0.2019. So 0.2019, but that's only the area, remember, from here to the center. That's all we get when we look up a z-score, from the z-score to the center of the curve. If I look up 0.27, I'll get the area from here to here. Let's see what that gives us. So again, 0.27, here's the 0.2, right? And then if I go over to where 7 is located, I'll get the answer 0.1064, or 10.64%. So 0.1064. Now, since I'm shading between these 2 points and I've shaded across the middle, I'll have to add the two answers together to get my final answer. So 0.2019 plus 0.1064. And 4 and 9 make 13. Carry the 1. I'll have 8 here, and then 0, and then 3. Or in other words, 30.83%. So that's my final solution, written as a percentage.